mentioned before in the video, an emergency can happen in any situation and without any warning. It is best to keep ourselves and our loved ones safe. My name is Benedict, Division Secondary, Area 3. Chapter numbers are 61,000 and 3,100. My information is also displayed on the screen. Today I'm here to talk to you about the next step into patient and self-care. By me, Benedict. The problems with modern healthcare, as presented on the screen, is that it takes time to assess patients. It takes time to take the patient's blood pressure, oxygen levels, pulse, cardiac rhythm, blood glucose, red, white blood cell count, etc. Not to mention the time that it'll take to transport these machines to patient to patient. And these machines that are required to take these vitals takes a lot of time to boot up as well. So my answer to this is AVA. The technology that will save millions of lives. AVA stands for Advanced Vital Assessment Implant. The patients will have the option to implant themselves with AVA right underneath their wrist, and this will help them save time in an emergency situation and help them better understand their body. Before we can talk about how AVA will save lives, let's first talk about its main components. The coils. How these coils work is that one coil will be implanted underneath the skin and the other one will be inside of AVA. These coils, when presented with electricity, will create an electromagnetic field that will be able to send back and forth information to them. That is how AVA will be able to communicate to the user via an app. The batteries. The main battery, as presented right here, is a 500 milliamp, and the two small batteries are each 80 milliamps. These two small batteries will be responsible in order of creating the electromagnetic field that are presented in the coils. And the main battery, the 500 milliamp one, will be in charge of running the entire component of AVA. The main board. The main board will have the obvious use of managing, collecting, and sending data throughout all of AVA. The main board will have a total of 3 gigabytes of storage. Two are found in the exterior of AVA, and one will be found in the actual component, which is presented right here. The pulse meter. The pulse meter will be used to measure the slight compressions within the artery, which will be resembled to the heart's pulse. The rubber itself has 3 wires right all around the cross that detects movements in the capsule that resembles the pulse. The information will be sent to a digitalizer and sent to the main board. The blood filter. This disc will serve the purpose of containing 3 milliliters of blood in a single spot. Then the digiters will process and capture an image within the inner filter of where the blood is. The picture will be at the level of a microscope, and then you convert it into binary that will erode the image containing the red and white blood cell count. The information will be sent to the main board. The temperature tube. The temperature tube is found in the lower half of AVA. The temperature sensor uses electromagnetic signals and voltage across diode terminals. When the voltage increases due to its diodes, that is the same as the temperature increasing. The temperature tube will then send the temperature that was increasing being used as to a digiter that will be sent to its main compartment. The respiration wave transmitter. The respiration wave transmitter will analyze how frequently and how much quantity and the force in which oxygen is being inhaled and exhaled. With this information, the transmitter will use diodes to mark the increasing and decreasing of waves and will be able to display them to the main board using its compartment right here. The glucose and blood sensor. The glucose and blood sensor is the first component that goes into play when blood is first inserted into AVA, starting with these 2 little tubes. The sensor itself is found in between these 2 little copper wires. The digiter will send an electric signal that will match the glucose concentration in the blood, and that will be how it determines the glucose within the blood. The oxygen sensor. The sensor has a little light beam that is flashed at the blood that is inside the tube. This light will be then used to analyze the blood and estimate the oxygen amount, the oxygen saturation that is shown within the red blood cells, and then the information will be sent from these pads to a digiter straight to the main board. You've heard me mention the digiters a lot in this presentation, and here we'll have to explain them. These are the digiters. Throughout all of AVA, there can be found 5 digiters. These digiters are the ones that will collect the raw information, simplify it, and then send it straight to the mainboard. These digiters themselves have boards attached to them so that they can process the information they are given according to their unit. The electrode strips. These special electrode strips are connected from both sides to the transmitters that will erode information from the main artery towards by stretching those tips at the end of AVA to get a full-length measurement straight from the artery. This code will be sent straight to the mainboard, where it will be decoded in a wavelength image with a powerful and constant precision. The NFC transmitter. The mainboard will be directly connected to the NFC transmitter that is located above the battery for a quick and easy voltage access. The NFC transmitter will give this information to the user and ask for a passcode via an app. For an emergency situation, first responders and hospitals will apply their own code, and then the app will register the situation as an emergency and give access to the information, and AVA will have an emergency situation give access to the information, and AVA will have open access until prompted to lock again. The blood pressure sensors. It begins with having a small wire that is found within the center of these 2 cuffs. Then, as blood flows into these cuffs, the air from the pulse meter will be pumped straight into the cuff that will create pressure around these cuffs. Then the small wire will copy the pressure and send it to a digiter that will be represented as the blood pressure itself. One cuff will be used for diastolic and the other one will be used for systolic. Once again, the Advanced Vital Assessment Implant, otherwise known as AVA.